Hello and welcome to the tutorial of the pesticide phase tool. So first of all, let's select the region of application. So in this case, we already selected the Campania region. The tool can be found under the Challenge, Land Degradation and Sustainable Development Goals, in Nitrates and Pesticide Directive, Groundwater Vulnerability Dynamic Modeling, and there is the Pesticide phase tool. So the model requester, we have to choose firstly the region of interest, which is already drawn. So let's choose this one. Because it is a particular important zone for the cultivation of wheat. Let's choose a start date between 2008 and 2018. Let's do a simulation considering 1 year, so the 2008. So the end date is the 2008, so the tool works at yearly time scale. That's why you have to choose the entire year of simulation. We select the land use, as we said, the winter cereals. The land use varies according to the choice of the scale, according to the suggestion that we got from the local farmers. And then we have the list, the associated list of pesticides, again suggested by the local farmers. Let's, for example, do a simulation using the glyphosate. Then we can click on the evaluate button and wait for the results. We already prepared a simulation, an equal simulation, so let's click on this one to see the results. So results are presented both as a table and as a map. Let's firstly open the map. So this is the our region of interest. You can see the soil polygons within our region of interest. So we have 4 soil polygons. The map has a legend. Okay, so the legend classifies the percentage of arrival of the pesticide at the groundwater table depth at the end of our simulation period. As you can see here, everything is green, which means that almost zero, arrives at the groundwater table depth. Here we have all the results expressed for each soil polygon. In fact, if we click, the soil polygon is selected. And we have information about the water table depth, the crop we choose, the pesticide, the total input mass of pesticide in 1 year of expressed as kilograms per hectare, and the output expressed as micrograms liter. So as you can see here, we have that nothing arrives at the groundwater table depth at the end date of our simulation period. We have also this action button that you can click, in which you have the evolution of the arrival. In this case, as we said, we don't have nothing at the end of the simulation period, but also later, because the model is able to estimate the entire transport evolution in time. Okay, results can be also seen here as in the results table. So we have the 4 soils and the area, the soil classification, the output mass percentage, so the ratio between the output and the input, and the input expressed in kilograms per hectare. Thank you. See you in the next tutorial.